friends. Thank you so much for being here. Welcome to How to Trust a Liar, Instrumenting AI Execution with OpenTelemetry. My name is Whitney, and I'm a technical advocate at Datadog. So have you noticed this trend in tech that now that there's AI-assisted coding, like everyone and their mother thinks they're an application developer now? Yeah, it's me. I'm an application developer now. After spending the last 5 years working mostly in DevOps, I've been, I'm still doing a lot in DevOps, but I've been making my own application, and it's been actually an absolute joy. What I've done is I've made an automated engineering journal that's just designed to be used with Cloud Code specifically. It's triggered by a git commit. It takes your git commit message and your code, like the code diff, plus all of the messages that you exchanged with Cloud Code while you were developing, and then it automates an engineering journal entry for you. But let's just jump right in with the demo, and I'll show you how it works. So I'm going to talk to Cloud Code. Here we are. So I'm using a tool called Whisperflow, so I could just directly talk to Cloud Code. So Cloud Code. Commit the staged changes with the message, observability day. Woo! Ow, ow, ow! Boo, 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 boo! Yes. So, Quad Code, I got that part wrong. Okay, so now Cloud Code is going to, what is happening? Oh, because I did it and I'm not onto Cloud Code. Here we go, let's try it again. Cloud Code, please commit the stage changes with the message, observability day. Ow, ow, ow. Woo, woo, boo, 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 boo. And here we go, now we got a real one. Cool. So now what's happened is I have instrumented my application a lot with OpenTelemetry. So now it's going to commit the changes, and it runs as a background agent. Let's get the commit going. Good. But I have it running in dev mode right now, so it's going to give me some logs, which is great. That's what I want to see. Now here in my code base, what is going to happen in the next few seconds is that I expect a new journal file for today to show up. And then it's going to have a journal entry that was just created with all of the changes I've made since the last time I made a git commit. And here it is. So here is my commit. We have our commit message, ow, ow, ow. And my journals, they make they use three different AI journal generator functions. And under the hood, one of the journal generator functions makes a summary section. And then that's just a summary of everything I talked with Cloud Code about since last time I made a commit. Then there's a development dialog. So this has literal commits, literal dialogue that I had between me and Cloud Code. I was talking about observability day, go figure. And then I have a third section, which is a technical decision section, which is meant to root out any of the technical decisions I made and whether or not I just discussed them or whether I actually implemented them based on the code. So that's what my journal does, but that's not the point of today. The point of today is to show you how I'm using OpenTelemetry to interact with Cloud Code and give more context and how it improves my coding experience. So I want to show you how much Cloud Code knows about my application. So this is, I'm actually maybe a little nervous to even give this at observability because I'm using OpenTelemetry so wrong. So I've instrumented every little thing, like every beginner does, every little helper function, everything. Because my point isn't to be like, what can I see in production? My point is to understand what can I help tell my coding agent about what's happening in my code base right now. So I'm going to talk to Cloud Code again. Get the trace ID from the console logs. Using this, plus the correlated metrics and logs, draw me a diagram of how this system works. Search smartly and minimize token usage, and add some color with a sprinkling of telemetry facts. I especially want a detailed diagram of how chat data gets collected and filtered and prepared for the downstream journal generator functions. Again, don't use too many tokens. Don't embarrass me in front of my friends. All right, so while it works on that, so I'm gonna be honest, I usually, I've given this talk before, and I usually give it to a non-observability audience, so I usually maybe Oh, I just need to re-authenticate to Datadog. No biggie. We got this. Escape. We're going to MCP, reconnect. This is how you know it's real and live. There we go. We'll just do it again. And so I hemmed and hawed about whether to make this a little less what is OpenTelemetry, but really, when my first KubeCon was in 2021 in LA, and I went to day 0, and I went to PromCon, and I had this idea that by going to PromCon, I was gonna learn about Prometheus, which is an absolutely, like being there from the second it started, I was like, I have no idea what's happening. So I'm gonna go ahead and give this to, as though, there might be people here of every level, and I want everyone to feel included. So therefore, I'm going to talk a little bit about what it means to instrument everything with telemetry. So what is happening is here in the Datadog. So what a trace looks like, what I can show you here is, so with that trace ID, I just need to refresh. I'm a little nervous. So now in the Datadog, so I'm using Datadog now, but you don't have to use Datadog. This is OpenTelemetry. Part of the point of OpenTelemetry is that it's vendor agnostic, but I work at Datadog, so therefore I have free Datadog, so therefore I'm going to use Datadog. Also, Datadog's great, but that's not the point. So I'm looking at commit story main, and you can see here the purple ones are OpenAI calls. So a trace, this is called a flame graph, and it has a parent trace of everything that's happening. My whole journal call, the exact journal call that you saw me do was this main trace. And then you can see it's gathering context. You can see it's doing a connectivity test, so it fails early if it doesn't work. It's generating the different parts of the journal, and then these like baby little traces here at the end are creating the directory and doing the different right things that it needs to do. And then I have correlated logs and metrics. So from this trace, I can see every log that's a part of it. And I've specifically given like pretty narrative logs because I want my coding assistant to be able to read these and understand what's happening. So back in our slideshow, you can see all my speaker notes. So it's not like I'm really looking at them. It's not back to demo time. We need to see the diagram that Claude Code built for us. Look at that. So I want you to note that I cleared the context at the beginning, and so everything that's here, it came through telemetry knowledge. So I instrumented my code and went to a telemetry backend. The Datadog MCP server reached to the backend, pulled the telemetry data in here in my coding environment. So I have it when I'm coding. So I have, you can see the commit story main. We can see it's gathering context. We can see it runs that. It does the filter and prepare of the messages. So we have 31 messages as a result, and we can see it started with 1,078 chat messages because it's looking at everything on the machine. It's making those journal generation functions. It sees that. It understands how the saving is happening. And here it is zooming in on the chat collection pipeline. Find the chat files, group by session. So sometimes people have more than one tab of Claude Code open at the same time. So we want to group by session so that the AI can understand it better. We're going to filter messages. We're going to do context capture. That's part of an MCP server. Don't you worry about that. And then some telemetry highlights. So it knows a lot about my code base without doing any of the normal grep for pattern and static code analysis that it normally does. So back to the slides. Here we are. Cool. So OpenTelemetry is a model for how to translate system events into useful data for observability. When I was new to OpenTelemetry, it was especially hard to wrap my head around this because there's so many spinning plates, there's so many moving parts, and people might say OpenTelemetry when what they mean is the standards, what they mean are semantic conventions. People might say OpenTelemetry when what they mean is they're talking about OTLP or the protocol. Sometimes when people say OpenTelemetry, they mean software, but that would even be easy if there was one kind of software. There's like 3 different pieces of software. So are they talking about OpenTelemetry APIs, language specific, that translate translates code level events, language-specific code level events into useful data? Or are they talking about SDKs, or are they talking about the collector? So there are a lot of different pieces moving when we're talking about OpenTelemetry. Again, I'm using telemetry totally different than what's normal because this is a new use case for telemetry and I'm experimenting. And honestly, I'm having a lot of fun. So now to the next demo, which isn't really a demo like you've seen before, because I want to talk about how, it's cool that it can draw a diagram, but how does this actually help me in practice when I'm actually coding? So I can't reproduce this. I had a really nice exchange with Claude Code that really illustrates all the different ways it can help, but I can't make that happen again, given that it's not deterministic. So what I'm going to do is I'm going to do a dramatic reenactment of my interaction with Claude Code. So again, this is based on a real experience. Yeah. What is it that they say in the people are fictional, the events are real. So here we go. Claude Code, I have a problem. The dialog section of my journal isn't generating. It's timing out. Look at the Git diffs to see what changed in the code recently that could have caused this.
You're absolutely right. Use the diff first.
Whoa, Claude Code, are you Scottish?
Looking at the code changes, I see you updated your prompts to better explain the data schema to the GenAI model.
I did.
These more detailed descriptions have token overhead, and that is what is breaking your system.
Claude Code, I really doubt that a schema description is the problem, but it is something recent because I haven't noticed a journal generation function failure before. So I want you to use telemetry to examine what data is being passed into this function right now.
What a smart approach, using telemetry over guesswork.
It's a fine approach. It's pretty standard debugging stuff.
Using the MCP server to query the backend, I see that the function inputs are massive. This proves our idea. The data schema descriptions are adding to the input and creating this generator timeout. Let me trim down the descriptions for you.
Oh my God, stop Claude Code. It is not that. Those inputs are too huge to be explained by data schema descriptions. I want you to set a breakpoint so we can see the actual literal data being passed into the failing function.
This is brilliant. We already know the input is huge. We need to understand what is actually being passed in and validate our schema description theory.
It is not the schema description. Oh my God. But whatever, just run the test, Claude Code.
After running the test, I see the problem. And it isn't the bloated schema description.
You don't say.
It is that raw chat data is being passed in. Every message that passed between a developer and AI assistant during the commit window. This includes tool calls, each which could have massive 1,000-line prompts. There are 448 messages here.
We figured it out. That's great.
You are so smart and wonderful.
Stop.
The answer is to filter out these big tool calls. Want me to modify the dialog generator function to do that?
Hold your horses, Claude Code. For once, I agree with you about the actual problem. There's too much chat data that's overwhelming the AI invocation. And I also agree about the solution that these big tool calls need to be filtered out. But before you write that functionality right here, I want you to use telemetry to see whether the raw chat data is making it to the other journal generators too.
You are amazing. This is the right approach. From the telemetry, I can see that the massive raw chat data is being passed in to all three journal generator functions. Let me see how the system works.
Claude Code's going to do it his usual way.
I'll do this my usual way by grepping for keywords and doing static code analysis. Got it. I will add the new context filtering code to the context integrator layer where other message cleanup happens.
This seems good, Claude Code, but it still isn't quite right. It doesn't explain why the failure only recently became a problem when we've been successfully generating journal entries for like a month or two now. I also vaguely remember adding this filtering functionality in before. So what I want you to do is use trace data to understand the full system flow.
You are wildly intelligent. I will follow your brilliant advice.
This flattery does not make me like you, Claude Code.
From querying the telemetry backend, I see that the system already has filtering logic. Here's the function that already filters the tool calls and system messages, reducing 448 messages to 174 messages.
But the journal generator...
Yeah. But journal generators were receiving the full 448 messages, bypassing existing filtering.
Oh, you know what? A few days ago, we added functionality to better support users who run multiple Claude sessions in parallel. Specifically, we started grouping chat data by session ID before passing it to the generators. I bet that's when the filter helper started getting bypassed. So Claude Code, I want you to verify this, and if that's indeed what happened, I want you to fix the code so the existing filtering reaches the journal generator functions.
You are absolutely right. I just verified with Git that this is indeed where the issue started.
Great.
As usual, you're a genius. The fix is working with minimal code changes. Problem solved.
Claude Code, I do not believe you. I will never believe you until you show me data. Use telemetry to show me that the fix is working.
The Datadog traces confirm the fix is working. Here, have a look.
Yep, they confirm, thank you. That's it. I now consider the problem solved.
You are God's gift to computing and to all of mankind.
So you know there's a term for when Gen AI goes overboard with the compliments? Like, there's a term for this, it's called glazing. And the thing I hate, there are two things I hate about it. One is, I just feel like I'm being manipulated into liking you more, and I don't like feeling manipulated. And then B is, it's costing me tokens. All these compliments cost money. Yeah, I don't like that. So anyway, back to telemetry. We're going to get back to the code. Calling this one a demo is an overstatement. We're going to look at the anatomy of an instrumented helper function. And honestly, I'm new to OpenTelemetry, so you all might have some stuff to teach me about what I'm doing here. So let me flip to the right screen and then bring you on board. So here I am. I'm going to open up this journal paths file. And it's a function. It takes in a date, and it outputs year, month, day, month-dir file name. So it outputs these things and basically the stuff it needs to build a file name for a new journal file. And so the trace starts at the beginning of the function, and it ends way down here. So the function has a lot of code to it. And the actual business logic in this code is just this much. It's barely anything at all. And so the trace itself is going to tell you the amount of time that is spent executing that particular function. But there's a lot more data we can collect while we're in here. And so we can give our trace attributes. And so we're going to do that. And then we can also have correlated logs, metrics, and traces. And we'll do that from starting the logger and doing metrics inside of this trace and then passing the trace ID into those two things. So it's all correlated with one another. And that's demo 3. And we're back to slides. And I'm going to go over some benefits that I've experienced from development time telemetry data. So I noticed a few ways. One is I've used Claude Code to disprove wrong assumptions. So Claude Code can get fixated, or when I say Claude Code, I mean any coding assistant, can get fixated on the wrong idea. And telemetry has been a great way for me to pull it back into this is what's true. And here, once you discover it's true from some real data, you'll believe me because you don't believe me with my words. The second thing development time telemetry helps with is debugging assistance. And so in the reenactments, I use telemetry to get general information about what data is being passed into the problematic function. but I could have done better. I could have done better. What I should have done in retrospect is I should have said, this was working 3 weeks ago. Tell me what was passed into this function 3 weeks ago, pass it and compare that to what's going into the function right now. What's the difference there? And then I could have pinpointed the problem more quickly and honestly figured out that the filtering already exists at that point earlier. So I could have done better, and I'll do better next time. And then another thing it helps with is it gives us a holistic system view. So in the debugging example without telemetry, Cloud Code tried to rewrite existing filtering functionality that my code base already has, and it tried to do it twice. It tried to do it at 2 different places in the code base. And this is really the crux of it for me. Like, if I would have let it write that functionality either time, it would have fixed my problem, and I would have moved on, and I would have had a bloated code base. And so in my experience, it takes real work to steer Cloud Code in a way that keeps your code base clean. So it's pretty easy to get Cloud Code to write code that works, and it's pretty hard to get it to write code that's like good and nice and keeps everything tidy. So that bloat is hard to stop, and I think telemetry could be the key or one of the keys to stopping that. Another benefit is that it can help validate code changes. I will never, ever, I do my best in my life to never, ever, ever believe Cloud Code unless I see data. So Cloud Code, oh, we did it, we're done here, goodbye. It's like, no, 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 no. I gotta see it or it didn't happen. And then outside of this example, I also use development time telemetry to help me design informed solutions. So when I was deciding how many quotes I want to feature in the dialogue section of my journal, I could ask Cloud Code, like, about how many useful quotes come in here in the first place, and kind of choose, that will help me choose how many I want to feature. Which I should have flipped through some slides when I said that. There are many drawbacks and unknowns too. This is all, I'm playing with a brand new frontier, so who even knows? But the biggest one is cost. I've done all of this without any concern for cost. Well, some of you may know a lot better than me, and you can tell me later, please. Actually, please do. I don't think that the cost of actually storing the telemetry data would be that much compared to the level of production telemetry data you're storing. I do think maybe there would be cost involved, well, there definitely would be cost, but maybe a prohibitive amount of cost involved in all the tokens it's taking to move the data to and from the back end to your coding agent. But that's just me taking some guesses. Cloud Code will make wrong assumptions about telemetry data too, just to be clear. It might make maybe slightly fewer wrong assumptions because it has more knowledge about your code base, but it will find a way to assume the wrong things. And it did in my debugging example earlier. It's like, oh, we're receiving a massive input to this function. It must be those those 2 paragraphs of more schema description that you added. So I made a wrong assumption. Another problem, and one I imagine that you're thinking about, especially since I showed you instrumenting a little teeny helper app, it seems like a pain in the ass to instrument your code to this degree. Like, how are we really going to get the developers to do that? Like, is this enough benefit to have them do that? I think it's a valid concern. How I handled it personally in my own code base is that I made myself an agent. And so I run a /add telemetry command, and it finds any new code that was written, and it compares it against the telemetry standards, like OpenTelemetry semantic conventions, plus my own code base standards, and it instruments my code automatically. And it does so, I think, with reasonable success. And then the final concern I have about this approach is how do we instrument code for development and for production at the same time? This, I'm learning OpenTelemetry, and I think that the separation of concerns between the API and the SDK can solve for this, where we instrument everything, but then use the SDK to only collect the things we want for production, but I haven't validated that. And that is all for my presentation today. I think it's been really useful to instrument your code with telemetry for a development use case. And thank you so much. This has been a joy. And thanks so much to Chris Plank, who is the voice of Cloud Code. Yeah.